Okay, great. So today we have two topics to cover. Today we're going to be looking at Learning Unit 4 and Learning Unit 5, and then next week we've got the last two topics, Learning Unit 6 and 7. Right, so this week I'm just going to follow the actual study guide outline in terms of what they want you to cover, and then we'll reference content either in the textbook or with the notes that I've shared with you. So the first thing is quite simple. It's kind of like a follow-on from last time's content when we had our session. We spoke about financial statements. You just mentioned now the statement of cash flows. Okay, so these statements are actually spoken about in Learning Unit 4. They talk about the structure. The focus here is obviously corporate financial planning. So businesses obviously need to record their financial performance. They need to look at their financial position. So everything in accounting needs to be recorded in these financial statements. And you can obviously use Excel to build a working model that basically takes information and models that information in order to create these statements. So that's the first bit. Then obviously they bring in some of the analysis. So following on from our first session, we said Excel is a very powerful tool because it has some of these built-in functions or formulas that you can use to actually do calculations. So when you're doing any form of analysis, you've actually done quite a lot of analysis in some of your other modules. If I just look at your FIN3601, you did some analysis there in terms of financial statements. In 3701, you did more analysis, looking at time value of money. You also looked at other measures, looking at financial performance. Break-even point you should also be familiar with from one of your previous modules. So there's a lot that you can do on Excel that's purely number crunching, let's call it that, where you've got lots of data, lots of information, and then you can analyze that information. You can complete some sort of analysis, and you can even do interpretation. In other words, you can graphically represent information. So I saw this week there was a note about linear regression and that. So I think that's the first thing that popped up in terms of the notes. So I've got this slide here, handling of data, because this is related to statistics, and obviously Excel is a very powerful tool that can handle a large number of data, where you've got raw data or processed data, it doesn't really matter, and you can do these statistical measures or calculations. All right, so first thing, just to highlight scope, okay, just to give you some context here in terms of what the actual topic is looking at. So corporate financial planning obviously involves information and obviously analysis because we need to make decisions. All right, so introduction, we just looked at that. Financial statements, a lot of this comes from or spills over from last time. So when we looked at an example where we had to like download data for a specific company, if I remember correctly, your company was, I think we looked at Pick and Pay or something, and your
Yes,
company was
outsurance, I
Outsurance,
think.
yes, that's it. Okay, correct. And then you had to use their financial statements for the previous years to basically recreate an Excel version of the data with all the inbuilt equations and so on. So this whole course is looking at your ability to use Excel. So just remember, if you do answer any future assessments or assignments, always try bring in as much of the Excel as possible. Okay, if you can automate something using a formula, do it. Okay, if you can reference something using a formula or using something that's inbuilt into Excel, try use it. All right, so even if it's like a date, you'd want to use maybe like a date function, or if you're adding, for example, a simple summation just to add everything up rather than using like addition as in like plus plus, so each cell adding each cell, rather use some of the built-in functions. I do think they'll look at that and they'll obviously award marks based on your level of competency when it comes to using an application like this, okay, on a platform where you have almost like freedom to create these different, let's call them models, okay, because in the real world, you would be using Excel to model various real world scenarios based on actual data that people would collect. Right, so that could come from surveys or financial statements. It all depends. All right, so there's an example here. Notice they're referring to the previous chapter. All right, you've got different cells. So remember, columns and rows. Okay, and you've got all this data, this information. All right, so just remember when you're doing analysis, before we can do the analysis, you need to import or create the actual statement. So I don't know if they will probably use the same scenario for later assessments. My thinking, if I was setting the assessment, I would probably use your first assignment as a guide, maybe give like students a memo or a model answer with the actual financial statements, and then from there, then ask them to do analysis. Because obviously every student's answer might be a little bit different, but if you're doing analysis, you need data, okay? You need information, and then with all of this information, you can then do certain workings and calculations, all right? But remember, it's all built in Excel. Excel is very powerful. You can highlight the different line items that could be in an actual income statement or balance sheet, okay? Those are the old names for it. So statement of comprehensive income or profit and loss. And then you've got the statement of financial position, right? And you also have cash flow and changes in equity. Every single statement that we have in accounting can be recreated in Excel using all these tools. Okay, so this is just data. This is an example. They're just showing you what they've used before. Notice this is the first time where they're talking about these inbuilt functions that you can make use of in Excel. Right, so they've spoken about the average function, and the average function is useful to estimate past cost of sales and selling or expenses in a useful way to get a rough estimate. Okay, so remember in statistics, you're going to have lots and lots and lots of different years or months. You're not only going to have one. So if I go back to that spreadsheet we were working on last time, okay, obviously here we had 1 year, but you could have multiple years. So I'm just going to use a separate sheet, a new sheet. I'm just going to move this one to the end. I'm just going to put a little note here. Let's not call it averages. We'll just call this analysis. Right, because the analysis is related to the data that we're going to be looking at. But I just want to demonstrate something. So for example, let's just assume you had sales, okay, just to keep it simple, and then you had the months from January all the way through to December. Okay, you've got 12 months. And let's assume they gave you an amount, okay, representing the sales during the year. Right, we'll put some bigger amounts, we'll put some smaller amounts. Okay, something like that. All right, and then obviously, if you were looking at, let's say, analyzing your performance, if you were a business manager or you were the sales manager and you were managing a team of consultants that were going out to sell various products to different individuals, you would obviously want to track their sales, and you would want to get some sort of measure that can help you and analyze or manage your area a lot better. So if I'm looking at sales specifically, obviously the total sales would be important, and that I could calculate just using the sum function. I could just take all of those cells and I could just add them up. Okay, so if I'm looking at an average, okay, you know from mathematics, an average is the total divided by the number of events or observations. Okay, so if I know what the total sales were for the 12 months that I'm looking at here, okay, then I'm going to look at dividing this total. So this amount divided by 12 would give me my average monthly sales for the business. Okay, so if you look at the average, right, you could then see, you could almost forecast, or not forecast, but kind of like predict in terms of your analysis. Okay, this is a very powerful tool that can help you. So the textbook also talks about forecasting. They referred you to one of the chapters where they referred to forecasting actual like line items based on the financial statements. So just to use that same word, okay, forecast or to predict, right? It's a very useful way to analyze performance, okay? So if I know what my average is, all right, then I can take that cell. So I can say the change, okay? What is the change or what is the variation, okay? Or what is the, inverted commas, the deviation, all right? A little bit of statistics. I don't know how familiar you are with your stats. I'm just going to ask you, have you done any of the stats modules at UNISA? There's a STA 1501, there's a STA 1502. I know the STA 1502 does a lot of this. They do a lot of regression analysis. They do deviation, standard deviation, variance, all of that. Have you done quite a bit of stats in the past or not?
Not done any of the stats modules.
Oh, you haven't done any?
No.
Wow, okay. Are you familiar with the concept like standard deviation?
Yes, I think I did do it in quantitative elementary, some module.
Okay, that's good.
Yes.
Yeah, you might have done it as part of maybe a maths course, perhaps. Yeah, you do get specific stats courses at UNISA, but yeah, you also get the maths courses. Some of them might have some statistics. That's true. So, all right. So as long as you're not unfamiliar with these concepts, so I'm using various words just to explain it, but if I know this is my average, okay, I know that's my average, I've calculated it. If I was working out a deviation, I can fix that cell. So to fix a cell, when I press equals, okay, the deviation, let's use that column or row, all right, deviation, I can click that cell, all right, it's referencing 08, okay, there's it in the formula. If I press F4, oh, excuse me, it's gonna fix the cell. When I say fix the cell, it fixes the row and it fixes the column. So this is the dollar sign represents you're fixing that particular formula. You're not going to change the row, you're not going to change the column. And then I'm going to say, because I fixed that column, I'm going to look at the deviation. So actually, I need to choose this cell first, and then I need to subtract this cell. Okay, because my sales for January were 10,000. My expected average sales per month is 43,166.67. So the deviation would be negative 331667. So I could say, well, in that particular month, January is a bit of a slow month, perhaps. Okay, maybe we're coming from Christmas, so they've spent most of their money during the festive season. January might not be such a good month for our store. Maybe there aren't as many customers coming in to buy things, whatever the case might be. But remember, it's purely analysis. And if I copy and I paste this, okay, you can see this formula is updating based on that fixed cell that I've referenced in my equation. So I can reference the cell and I can fix the cell. I can fix the column and I can fix the row. All right, and I can literally copy paste this now, okay, for all of those months, and it's going to show me all of the different values, okay, based on the calculation that we've done. All right, so some of these figures are good, some of the figures are bad. All right, in certain months we exceed, okay, our average monthly sales for the month, and in some instances we don't. Okay, we're actually below or less than what we would maybe expect. Okay, and that could help you with planning, or maybe like seasonality. Maybe if we were selling clothing, perhaps maybe, or selling any other item that maybe is linked to a specific season. Okay, maybe it could be ice cream or I don't know, something along those lines. Okay, where there's seasonality, where at certain times of the month you might be selling a bit more than the other. It all depends. All right, so just a simple example, very basic, simple analysis. Oh, I need to get some water. All right, it's fine. Okay, so just some basic, simple analysis. All right, when you're looking at an average. Okay, so remember, obviously mathematics can be used to work out the average, okay, but you can also use Excel. So if I say equals average, okay, there's different options here. So you can choose a calculation where you will get a result as well. So there's an A here, there's an if, you can make it meet a certain condition, all right? We're just going to use a simple one. Okay, and we want to work out the average for all of those numbers. Press enter, and what do you know? You have the same answer. All right, so you can do it using this, a mathematical equation, but because Excel has these functions inbuilt, okay, I would rather use this, right, for a UNISA assignment. Okay, obviously UNISA is probably going to be assessing you based on your ability to use these functions because they've already mentioned one of the functions here, okay, in your textbook, in your study guide, as a guideline, right? They've also asked you, right, to have a look at an example, okay, and to replicate the example in your own spreadsheet. All right, so we've done one example. Are you okay with this average function?
Yes.
Yeah, it's really basic. It's not that difficult to use, but just think about it in context as well and where it could potentially be used, right, if we're doing analysis. Right, so here's an example looking at different years again. It's a bit dark. They've just highlighted the first one, cash and cash equivalents. Okay, note for storyboard, this is included. The picture should play when embedded. Okay, so this is the author's notes. All right, I'm not going to look at that. Right, that's just an example. All right, the activity, here they want us to create a pro forma balance sheet, which you've already done. Okay, we've got that. Okay, you need to share that with the tutor. All right, I know you've been doing this a lot, so you just need to remember that if you want formulas to show up, all right, if you press Control plus and then that symbol, it's next to the one key on the keyboard, all right, next to the letter or the number one. If you like look at that, it's just above the reverse like apostrophe. Right? I don't know what you call this thing actually, but it's like an approximation sign. Right. This is going to help you show your formulas. Okay, so if I go back to Excel, all right, so there was an equation here, control plus, oh, that's not working. Okay, this might be because this is in the actual online version of it. I don't think we have the same. Yeah, this is actually increasing the size. Right. There should be a button here to show formulas. Okay, there we go. There we go. All right. Okay, so I think this is a very outdated study guide. This might have been the old Microsoft Excel, the one that you would install on your PC, not the newest version of Excel. This is the latest version of Excel. It's an online version. I'm just using it live on my account. So if you just go to your formulas tab, you will see a show formulas button, and then you can show UNISA all the different formulas you've used. Can you see there's an equation there, hey? And there's an equation there, an equation there, and some equations there. All right, so I do think at some point, maybe if you had to print this out, and if they had to mark this using a printed answer, then you'd have to show formulas so then they can see what you're doing. All right, so if you're also using a similar version of this Microsoft application, then just use these buttons or options here. You don't have to control anything, okay? This is a much easier way of either showing the functions or not based on the data or the spreadsheet that you're in. Okay, is that all right?
Yes.
Hey, awesome. Let's go back. All right, forecasting funds by iteration. So iteration means it's a repetitive process. So forecasting could be, well, I'm going to expect, let's say, inflation is going to be, let's say, around 4 to 6% every year based on the Reserve Bank's monetary policy. Okay, so again, another example. Let me just label this example 1. Okay, another example, example 2. Okay, this time I'm not going to have fuel expense. I'm not going to have months. I'm going to have years. So let's say, I don't know, 2000 all the way through to 2022. We could have many years. How many can we put there? Yeah, we can put 21 years. All right, so if you were looking at fuel expense, and let's just assume you had inflation between 4 and 6% per annum, right? And you were looking at forecasting, right, or planning, or another word for this would be budgeting. Okay, a budget, right, can be built, and you could alter and change the budget year on year, or even month on month. You could have a whole spreadsheet for 1 month, and then another spreadsheet looking at the years, taking all the months into consideration, right? You can have lots of spreadsheets if you want. It's totally up to you. Obviously, there is a limit on Excel, but the limit's quite substantial. It's normally linked to your PC, the amount of memory that it can hold. Right? Sometimes you'll get an error if you reach the limit, but yeah, it's very powerful. You've got almost an unlimited amount of rows and columns to use. Okay. So when I'm looking at fuel, let's just assume, I don't know, back in 2000, our business spent, let's say, 10,000 Rand on fuel a month, okay, to run the business, to fuel up all the delivery vehicles, etc., etc. All right, and then if you had to use inflation, let's say 4%, inflation, let's say 5%, inflation, let's say 6%, we could take this expense, okay, and we could model it month on month, or not month on month in this case, year on year. So we could say, well, if I expect inflation to average around 4% per annum, okay, per annum, how much would I expect to pay all the way here in 2021? Okay, or even 2023 if we had to go a bit further on. Let's delete this column and let's show 2 more years. Okay, maybe I should have started a bit sooner or earlier, but it's fine. Okay, that doesn't help. Let me shrink these. Okay, let's shrink these. Okay, yeah, that's going to fit. All right, and we can go all the way up to 2024, and we can estimate, or we can predict, okay, how much are we going to expect to pay maybe in that year. Okay, it's not very realistic because that's a 24-year time frame. Inflation is probably not going to average 4% a year. It could change each year, right? And that's a more complicated working. So you could maybe update it per year, whatever the scenario might be. But it's all modeling. It's just playing around with Excel and the features to try help us with forecasting something. All right, so if I look at that as the base, okay, maybe I can fix the cell again. F4, okay, copy it. It's not going to change, right? Same cell being referenced there, okay? And then I'm going to estimate. So if I'm adding 4% each year, I could just take that times about 1.04, okay? And that's going to add 4%, right? And then I need to take this amount times about 1.04, and I can copy that all the way through till the end, and it's going to continue to tally up. No, too big. Okay, that's a bit better. Right, and you've got all those figures. Right, and then you could do the same thing. You could even just copy paste these first two. You could just change that to 5%, 5%, maybe make that 6%, 6%, and then with all of these, I could just quickly, without much effort, okay, forecast how much that expense could potentially increase by at some future point in time, wherever it is. Okay, does that make sense?
Yes.
Yeah, so it's purely a repetitive calculation or process, right? There's lots of different ways of doing it. Remember, you don't want to do everything manually because it's very time consuming and cumbersome, right? It's better to rather try automate or to solve certain things automatically. Okay, it's a lot better. So try do that as well. Try show UNISA that as well when you're doing these different assignments. Okay, here's our first bit of statistics, trend analysis and regression. Right, I've given you some slides on it. I'm just going to skip to the actual regression. So maybe just to speak to what I've given you, this is obviously summation. This is just statistical notation, just highlighting, like summing up all these different amounts. And then central tendency is looking at these means, okay, these averages. Earlier we had an example where we had sales, and then we could just add all of it and then work it out using a formula, right? There's no need to do it mathematically. If you did have to do it mathematically, then you would use this. Okay, you can work out the average, you could even work out the standard deviation. All right, while we're on this topic, let me show you that as well. Okay, so standard deviation is actually a formula where you're going to have to work out the average of all of these amounts as it deviates from the monthly average. All right, so let me just copy this. Actually, let me leave this. I will just do it separate. It's not showing all the values. Okay, the cells are a bit too small. Okay. Right, so standard deviation can be calculated. All right, if I'm using, okay, let's just use the data here. Okay. All right, the first thing that you would need to do when doing a standard deviation calculation is, if you go look at that formula, the one in your notes, right, sample variance is basically the sum of the differences between the observed average, or the observed value minus the average. You need to square that, divide that by the number of terms, okay, minus 1. All right, so that's the mathematical calculation for calculating variance. Standard deviation is just the square root of that answer, of the variance. Okay, standard deviation, square root of the variance. So if I'm looking at a scenario like this, okay, the first thing you need is obviously the average. Okay, so we're going to take that. Okay, something's wrong with the, oh, okay, these aren't fixed columns. All right, yeah, those aren't fixed columns, so I need to paste them in the right place in this block. No, how many gaps here? 1, 2, 3 lines. Okay, let's try that again. There we go. Okay. All right, so this is being calculated using that figure, column N, row 34. This is looking at the average for all of these amounts, B34 all the way through to M34. Okay, so you've got those two figures. Right, if I had to do this manually, okay, which it is possible, but it just takes a lot longer to do. Okay, so the first thing I need to do is I need to work out the difference. Okay, in other words, what we had earlier, okay, this minus that. Okay, that's the difference. Copy paste that. Okay, then I need to square the difference. Okay, if I'm squaring the difference, I'm going to be taking this amount and multiplying it by itself. Okay. All right. And then I need to sum up all of the squared differences. Okay, so equals sum up all of these squared differences. Okay, all right, this is just exponential format. You'll see the numbers very big. Okay, it's just exponential format, scientific format actually, not exponential, scientific format. Okay, looking at exponents. Right, so that's the total. And then once you've got that, all right, we've got the total of the square. We need to divide this by n minus 1. So obviously n minus 1 in this case would be, how many do we have here? We've got 12. Okay, so I can count 12 minus 1. So n minus 1 in this case would be count close brackets minus 1, right? Did that add up? No, didn't work out the count. Let's just put another bracket here actually. See if that'll work. Still not working. I think it's because this is text, not numbers. All right, it's fine. Let's just leave it as 12 minus 1. Oops. Okay. 12 minus 1 would be 11. So this divided by 11, this divided by 11, okay, equals, this would be the variance. Actually, let me do it in this column. So we have the space, this divided by 11, okay, and that would represent the variance. Okay, obviously standard deviation is the square root of the variance. So square root of the variance, okay, gives you that figure. All right, notice this is the standard deviation for all of this using a very long formula, which was basically what we had here. Okay, do you have to do it that way? Not at all. Okay, there is a standard deviation function in Excel that you can make use of that can do that working in one step. All you do is STV, there's there, estimate standard deviation based on a sample. Click that one, right? We want to analyze this data. Okay, enter, and it's exactly the same answer. It must be. All right, so this is looking at your mathematical equation for standard deviation based on what we just saw here, summing up the observed values minus the average, all squared, divided by n minus 1. All right, so if I have 12 observations, I need to minus 1 to have 11, and then you get it that way. So this is a very time-consuming process. This is much better, and it didn't require much effort. It didn't require much time. All it required was, where's my data and what do I want to calculate? You can also calculate variance actually if you want to. Variance estimates the variance based on a sample. Click that, scroll, select all the data, enter, same thing. Okay, so you just need to remember, okay, mathematics, okay, remember Excel's a very powerful tool that knows how to do all of this on its own. Okay, you don't have to like work it out using all these steps. right? You can, but it's not necessary. If you know what standard deviation means and you know what variance means, let Excel calculate it for you and then get an amount and then use that to do your analysis. Okay, standard deviation, well, you can say, remember we also had the average, hey? So if we're looking at statistics, you could say, well, I've got all of these measures. Oops, other way around. Okay, I was going to write average here, or mean. Okay, the average or the mean here would be the average of all of that. Okay, so yeah, so what I'm trying to explain or show you with this demonstration is that these are statistical measures. These are tools, okay, inbuilt tools in Excel that can help you with your analysis, right? Your mean, okay, is your average, okay? Standard deviation is how far away does the data, okay, link to the actual mean. In other words, the deviation from the middle. It's almost like a bell curve, right? If the mean is in the middle, okay, how far away are you from the average? And the variance is just looking at that difference, that squared difference, highlighting the measure, okay? Well, a measure for the data, right? Highlighting something that we can use in analysis or in statistics to do more detailed analysis. Okay, is that all right?
Yes.
Okay, so there's a lot of things you can do here. That was just one of the examples, and there's a few more slides here. These are just basic examples. You can actually do this on the calculator as well. A scientific calculator can actually do this internally, all right? Mean, variance, standard deviation. If you want to practice this, you can maybe even do this as well. Let me just move this up. I don't know. There we go. Mean, there's the answer. If you want to try build a model on Excel using the tools that we've highlighted, you can just insert the data. The mean you should get is this. The standard deviation you should get is that. And the variance you should get is this, 72.28. Right, let's get to the straight line because that links to the linear regression analysis. Okay, so I'm sure you're familiar with this formula, right? Y equals mx plus c, yes?
Yes.
Okay, when you're doing statistical analysis, right, there's something called linear regression or linear regression analysis. Correlation is also something that's spoken about here, okay? When you've got a data set like this, where you've got lots of different observations, okay, you want to fit a best fitting line on the set of like data. So this straight line, obviously we can see it's kind of like sloping up, okay? So we would expect the trend to be sloping up. So linear regression is finding your best fitting line, okay? Taking all those points into consideration. Right, so there's an example here where I've given 6 points. So those are the 6 points. Just be careful with linear regression. You need to identify the X variable and the Y variable. It's important to understand which is independent and which is dependent. All right, so in my example here, your years of experience should be an independent variable, okay, that would potentially, based on statistics, possibly affect the amount of bonus that you perhaps get, right, if you are working at an organization. So X is what we're observing as independent. Okay, if I go ask somebody how many years of experience do they have in the organization, and I match that with the level of bonus that they might have received, okay, I can then plot that on a graph and I can analyze that data to get an expectation in terms of what I would believe is true. So I would expect that people that are more experienced to possibly get more or higher bonuses. It might not always be the case, but remember, it's just data analysis, right? There's another one here where I looked at a budget, okay, calculating and interpreting the linear regression line. So in other words, here you've got advertising spend and you've got sales, right? Does advertising boost sales? Yes or no? We would need to create a linear regression model that shows the actual relationship. And if I just delete the slide just to show it, when you work out your A and your B values, so when you're looking at linear regression, this is the format for the linear regression. A is representing the y-intercept for the straight line, and B is representing the slope for that linear regression model. Okay, so if I've got an example like this, and all of this I can actually plot on Excel. I can actually put all of this in Excel to work it out. All right, so I'll show that to you later. Let's just scroll down a bit. Okay. Oh, did they not show you an example of that? Oh, they want you to look at an example. All right, that's fine. Okay, let's do it then. I don't see an example here. I just see the next section. Okay, so yeah, we'll talk about break even. That's also part of the notes. Let's go back to the working document. Okay, let's put a little note here, example 4, and this is linear regression. Right, so linear regression is a straight line, y equals a plus bx. Okay, the a and the b you can actually solve using Excel. Let's first get the data. Just going to copy this through to Excel. Okay, so did I have any headings here? No, I didn't. Okay, let's just take the context as well, otherwise this doesn't make any sense. Okay. All right, so given the sales in millions and advertising budget in thousands for the last 12 months, calculate and interpret the linear regression line. Okay, so you saw what answer we need to get. We need to now calculate the actual amount, okay, the A value, the B value, and all of that. So remember, we're looking at linear regression. Okay, I want to show you what's in the notes because you're going to see these are even worse. Okay, this is how you calculate linear regression. If you want to work out B, have a look at that statistical equation. It looks very complicated, okay, because you've got two values. You've got X, so in this case, my X would be the advertising, and my sales would be the Y. Okay, so X would be considered independent. Why is it independent? I decide how much advertising I'm going to spend on, okay, and that would potentially affect my sales. If I'm analyzing advertising, I'm comparing it to sales, I need to check, is there a linear relationship between my advertising and my sales? In other words, if I do my linear regression analysis, okay, what does that tell me about the relationship between advertising and sales? Right, I would expect a link, but I need to mathematically prove it based on data that I have been tracking over the last 12 months. Okay, so let's go back. Right, you would use these formulas, okay, but you don't have to. All right, it's better to use either Excel or a scientific calculator. Right, on a calculator, you can actually insert these values. On your scientific calculator, if you use the stats mode, you can then calculate the A value and the B value using the calculator. Excel is better because it's easier. You've got all the data, you can just reference it. And then you can also calculate this coefficient, this correlation coefficient. The word correlation means, okay, how accurate or how much impact does advertising actually have on sales? All right, so in this case, the coefficient is 0.778819, which suggests a strong positive correlation. Okay, so in statistics, there's a slide on that here. When you have R as positive, you have a linear upward sloping correlation. So in other words, there's a positive relationship. In other words, for example, let's see, a positive relationship in a different context. The hotter it gets in summer, maybe we drink more water. It's positively correlated, right? So during hotter climates, okay, if the weather's hot, you're going to drink more liquids, more fluid, okay, to stay hydrated. right? Negative correlation, well, something in the opposite. So when one variable increases, the other variable decreases. So negative correlation could be, if we're looking at weather, maybe clothing. Okay, the hotter it gets, you wear less clothing. Right, that could be a negative relationship, perhaps. Okay, just a random example looking at this positive correlation. Do you understand correlation? Does that make sense?
Yes, that makes sense.
All right, so just remember that obviously we would expect advertising to be directly or positively correlated, or we would expect sales to be correlated to advertising. In other words, the more advertising I use or pay for, I would expect my sales to increase. Right. Not to say all advertising is going to lead to a sale, but it's a correlation. In other words, it's correlated. So this correlation coefficient is explaining the relationship between these two variables. Okay, did you manage all of that? Did that make sense?
Yes.
Okay, so let's do the working then. So I just want you to understand what you're actually calculating, so that when you get these measures, it actually means something. Okay, so linear regression analysis. Let's look for the values. Maybe just to show you this actually. Okay, we need to search for it. Okay, intercept, slope. Okay, there we go. All right, so you've got these two different options to help you with the actual calculation. Right, so let's start with the intercept, so the A value. Okay. All right, the arguments. Calculates the point at which the line will intersect the y-axis using the best fit regression line plotted with known x values and y values. Okay, so known y's, known x's. Okay, so for this one, I need to highlight this. I need to move this across. Okay, I need to highlight that. Okay. All right, for the x's, I need to highlight this. Okay. Hold on, that did it twice. Okay, I need to backspace, sorry. All right, let's do that again. Let's highlight the right data. There we go. Okay, so yeah, we only have to write it in once. And then this data, we've written it in once. Okay, good. All right, and then insert. Dividing by 0, there's a problem here. Let's put this in brackets. Oh, I think it might be the it might be the formatting. Let's just check that quickly. It's still saying divide by 0. There's no 0 here. I didn't see a 0. Let me just check. These are numbers. Hey, these are numerical values. Numbers. Okay, let's make these all numbers. Numbers. That might be an issue. Intercept. Are we selecting the right data? It looks right. Let's find out what's wrong here. The formula function uses dividing by 0 empty cells. I don't see any empty cells. That's odd. Let's see. Those are all numbers. Yes. Okay, those are all numbers. Yes. Okay, let's try that again. Let's delete it. Okay. All right, the intercept. Okay, maybe let's type the numbers out just normally and see if there is a problem with the formatting. I don't think so, but we'll check. 25, 31, 36, 88, 90, and 99. Okay, and then on this side, 9.6. Okay. All right, let's go intercepts. There we go. Okay, I don't know why it doesn't like that format. It's weird. Okay, I've just used that. It might be because of the numbers. I just copied it from that PowerPoint slide. Okay, it didn't like the numbers that I wrote in the PowerPoint. It's picking up a 0 somewhere, which is strange. I don't see any zeros, but yeah, the data's here. If we put advertising here and then sales there, okay, if we type in the values, then it seemed to have worked. Okay, is that all right?
Yes.
Okay, so I'm just going to leave that there. There was a problem with the formatting there. And then let's go, what is the other thing? The slope. Wrong cell. Okay, slope. Okay, let's do the slope. So yeah, we'll have to use this then. It doesn't like the formatting there. So let's again select what we want. The sales we expect to be our dependent variable. We expect advertising to be our independent variable, and that's our slope. Okay, all right, and if you go back to our slides, all right, there's the y. Okay, same y, I said y, same a. Okay, the intercept. All right, and there's the b. Okay, there's the b. All right, so you can do this in Excel. Okay, the correlation coefficient, they should have that as well here. There, returns the correlation coefficient, right? Ooh, wrong cell again. Okay, the correlation coefficient is going to be, I need to look at my array, so we have 2 here. I don't think it matters in this instance, but let's still select sales first, then advertising. Okay, yeah, looks good. Okay, same answers as the ones we had here. There's the correlation coefficient, 0.778819. Okay, so these are all measures in statistics that can be calculated on Excel. Right, and what's even more impressive is you can even plot this on a graph. Let me show you that. If you just select all of this and you insert this as a graph, okay, there's obviously lots of different options here. All right, there's a scatter graph. It'll scatter those points. There might even be one with linear regression as well. I don't think I have an option here for more. Let's see here. I think let's go with scatter, and then we can maybe add it to the graph. Let me just check the settings. No, it doesn't look like I can add to the graph. I have data level. Yeah, okay, this looks a bit better. Okay, the legend. Okay, no, that's going to show. Okay, I can't show the regression line actually. Looks like I don't have that option. Let's see if there's a different one. Is there another one that shows? All right, it might be because I have a limited features because I don't. This is just a free version of Microsoft 365. Okay, I'm not using a paid for version, but if you do have access to like a work Excel where you have the full version, okay, I can't use that for this. Obviously, this is my own private lessons, but yeah, you do have other options with more graphs. All right, I think this is quite limited because this is the not paid for subscription for the Microsoft 365, right? But the point I'm trying to make here is I can just show you this, and then that line that we've drawn, let me insert a little arrow, okay? What we've actually done is we've drawn that line, that linear regression line, okay, that would look something like that, kind of.
Okay.
All right, and that's basically what you're doing. Oh, what happened to it? There we go. Okay. In terms of linear regression. So the y-intercept, okay, the y-intercept, okay, it's intercepting at 9. So this is actually not correct. It needs to scroll up a bit. So it's a more shallowy sloping line because it'll cut that axis at about 9.1. So 9.1 would be somewhere there approximately. And then it would be sloping like that through all the lines as a best fitting line. Okay, that's basically what this is trying to tell you. Does that make sense?
Yes.
Yeah, so it's basically showing you a correlation. This would be, oh, I see some things popping up here on the right. Legends, horizontal axis. Oh, I have some options here. I think maybe here we might get lucky with the linear regression. There must be an option to add it somehow. Let's just see here. Trend line, maybe. Yes, there we go. I found it. Okay, here. All right, so if you click the actual graph, all right, wow, that was pretty close, eh?
Yes.
All right, if I delete it, okay, so yeah, format, I see it is there, but it's a setting, okay? And then we had to insert it. So we click the actual chart, and then it brings up these settings on the right. I had to go to series here at the bottom. Obviously, the series name I'm going to change. This would be advertising versus sales, linear regression analysis. Okay. And then I'm looking at the actual there. There's the linear regression. Okay, showing the best fitting line based on the data. All right, so yeah, looks like you can add a few other labels here. Series name. Oh, that doesn't look very nice. That looks quite good, adding the values. Okay, I think the values are quite nice. We can add that there. What else we can do? We can maybe change the colors. I'm not going to change any of the colors. I'm just going to leave it as is. Maybe we can add, no, we don't want to add errors. Errors aren't needed. All right, yeah, that's fine. I think let's leave it as that. Looks pretty good.
Yes.
You can make it bigger. And that's basically your linear regression. Hey, happy with that section?
Yes.
Okay, so yeah, it's yeah, you might have to like search and find these little features or these little like what can I call it? Settings. Okay.
I think I just also need to practice.
Yeah, I think that textbook is really great. The textbook does talk about linear regression somewhere. Let me just have a look at the textbook. Here, linear trend exponential smoothing, simple exponential smoothing. No, that's not quite right, but oh, there, regression. Page 186, forecasting the trend using linear regression. It is there in the textbook. All right. Okay. Let's go back to, okay, we've got break-even analysis and leverage. Okay, these are actually quite simple to calculate. This is something you would have done in finance. Let me just find the notes on it. Where did I put it? This is all bond calculations. Did I give you a note about break-even point? Maybe not. I might have left that out. Okay, break-even point is looking at sales, well, selling price, cost price, and fixed costs. Yeah, I don't think I've included it here, but I know you've done your FIN. Was it 3701 or 3702? I think it was 3702 where you had the break-even analysis. Or it might have been 3701 maybe.
No, I think it was 3701.
Was it 3701? Okay, do you remember that slide where you had fixed costs over the contribution, which is the selling price minus the cost price? Remember that?
Yes.
Okay, yeah, please refer back to that. I think I didn't add it to these notes because you've already got it from FIN3704. Okay, so just to explain break-even point is looking at your fixed costs. You're actually comparing fixed costs to your inverted comma, your contribution. Okay, your contribution is calculated looking at the selling price minus the cost price. Okay, that's break-even point in units. Okay, that is in one of your previous notes for, as you said, I think it was FIN3704. Okay, you can also do this on Excel, right? You can use the actual formula if you want to. I think Excel does have an inbuilt function for break-even point. Let's just check that. No, doesn't. Okay, let's just search the formulas for it. Break-even point, BEP, or break-even. Okay, no, they don't actually have it. All right, so it's not built in here. All right, this one is something that you might have to create then based on your fixed costs and your sales and cost of sales, well, your selling price and your cost price. Let's just have a look here. Okay, they're showing you different examples of how to break even. Okay, what do you understand by break even? Let me ask you that actually. What is break even?
Break even is when there's no profit or loss.
Yes, correct. Okay, where you have sales and cost of sales, or costs. Do you agree?
Yes.
Total costs. Yes. All right. So if you're looking at break-even points, right, you could also draw a graph potentially, okay, if you wanted to, and then you could maybe do the point of intersection where those 2 points link. Okay, so maybe let me show it to you graphically. Okay, break-even points. All right, so total revenue, total cost. I'm just thinking how we're going to do this because revenue will be based on price. We need prices. We need sales and cost of sales. So, I mean, we need selling price. So, and we need quantity as well. I'm just trying to think of the best way to represent this. Maybe this wouldn't be the best way. We'll need selling price, cost price, and then volume, quantity. Okay, so selling price, let's just use like, I don't know, 200. Cost price, let's use 100. Volume will vary based on different months. So let's use January again, all the way through. Let's just use 6 months. Okay, and then let's just assume the volume. All right, quantity, let's say 300 products, 400 products, 200 products, 750 products, 800, 350. Okay, so my selling price would be price times quantity. Okay, oh, I need to fix this one. Fix that cell. Paste, 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 paste. Okay, remember we're using Excel to do these workings. To show the examiner we can use the tools in the application. Total revenue, total costs. Okay. Total revenue would be sum of all of those, and the total cost would be the sum of all of those. Okay. All right, so if I'm looking at break-even point, we need additional information here. We need costs as well. We need fixed cost. That's cost, that's variable cost, so CP. And selling price. Okay, and then we need fixed costs. Okay, so maybe for the month of January, there were a certain number of fixed costs. Let's make it, I don't know, 40,000. Okay, let's make it 50,000. 5,000. Ooh, 5,000. Okay, 4, 8, and let's make it 10. Something like that. Okay, so total fixed costs. Those are variable costs. We need our fixed costs. Okay, those are our fixed costs. All right, so total costs actually, oops, what did I press there? Control bold. Okay, underline. All right, so this total costs, okay, we can group. This would be variable based on production. That would be fixed. And then you would have the total here. All right, and then this total cost would represent all the costs that the business has. Okay. All right, so break-even point in units would be fixed costs divided by selling price minus variable costs, or cost price, the contribution margin. Okay, so break-even point in units would be the fixed costs okay, divided by open brackets selling price minus cost price, close brackets, enter. Okay, so that would be the break-even point in units. Okay, and then in rand value, or sales revenue, okay, we would take the units and we would multiply that by the selling price. Okay, all right, so when you're looking at this analysis, okay, obviously revenue is going to constantly increase to a point. Okay, your costs are going to increase to a specific point, but we need to know, where do the costs basically, like, where does it intersect? Where is that, like, that point of intersection? In other words, where do the two lines cross? So we need a total revenue function, okay, because the revenue function is going to be your selling price, price times quantity, and then you've got your total cost. At some point, it's going to break even. Okay, so the total cost here was 41300, and obviously total revenue here was more, so we broke even, okay, at some point, which was at that point, so 1330 units. Okay, so how many units did I have here? 300, 400, 200. Okay, cumulatively I've got 900. If I add up there, I get 1,650. Right, so I would break even between March and April after having sold that number of units. Okay, so we're looking at break even at that point in time. All right, so if I sell 1330 units, okay, we break even. All right, at that point, which is equivalent to 266,000 Rand in terms of sales, okay, to cover those costs. I'm just trying to think of the graph, to draw this. If we use all of these variables, I don't think it will plot it, but we can try. Yeah, because we've got multiple values there and we've got values here, that would be a problem. Let's just have a look at that example they're referring you to. This example is where? In the textbook, okay? On page 209. Let's just see what the textbook says on page 209. Okay, I'm on page 188. I need to go a bit further. Okay, 209. Have you looked at this yet or not yet for this chapter?
No,
not yet, eh?
I haven't went through the chapter, but
Yeah.
in one of our assignments, I think it was assignment 3.
Yes.
We did have a question on break-even points.
I see,
but it was multiple choice, so it was pretty simple.
Oh, okay. Then want you to do any Excel.
No.
Okay, because I see in
that
the textbook
multiple choice.
Multiple choice, yeah. All right, because I see in the textbook they said linking break-even points to leverage, but then here they're bringing in degree of operating leverage. So this you've actually looked at before. In the textbook on page 209, they've actually given you that financial management. This is FIN3704 where you had degree of operating leverage. I see they've actually given you that formula there. Can you see it? On page 209. Yeah, and then they've given you degree of financial leverage, also same formulas. All right, so it looks like they've just given you formulas here. Break-even point is there, I see it. Fixed cost divided by price times price minus V, P minus V. That's on page 197. Okay, let's go to page 197.
Okay.
In the textbook. On page 197. Okay. That looks a bit better. Okay. All right, so there's a little note about break-even point, calculating break-even point in Excel. All right, they've given you a little table here, SPUDs and SUDs, income statements. You've got your sales, you've got your variable costs, you've got your fixed costs. Okay, so they've done it in a column. You've got your earnings, you've got your interest before tax, you've got your tax, and you've got your net income. Right, all of that's fine. Right, then you've got assumptions. Price per unit. Okay, unit sales, okay, and then variable cost as a percentage of sales. All right, that's fine. And then they've got a note here. We will first calculate the dollar amount by multiplying the unit price. Oh, okay, so there isn't an inbuilt function from what I can see here. All you have to do is reference the unique cells based on the actual data. So the data is given in column format. So they've just given you something like this. Do you see that?
Yes.
Okay, that's their example basically. Sales, cost of sales, and then they've just put a note at the bottom. They've said assumptions here. Okay, and then under assumptions, they've highlighted various things. Price per unit. Okay, then they've highlighted unit sales. And then they've highlighted variable costs. Okay, so it's actually a lot simpler than what I've tried to do here because I was looking at months. Here we're just looking at a period. So if this was 2024, wrong formatting. Okay, if this was 2024, okay, they're looking at this in your income statement, and at the bottom, they've got these assumptions where they have given you the selling price per unit, which is the SP. They've given you the number of units in terms of quantity, okay, and they've given you the variable cost, okay. All you've got to do then is take out the fixed cost that would have come from the question. So maybe under other expenses, obviously the notation here is not as good. Okay, I didn't separate fixed cost versus variable. but in the actual spreadsheet, in the actual income statement, there would be a line item highlighting the fixed costs. And then those assumptions would be used in order to calculate the break-even point.
Okay.
Okay, so yeah, Unita just wants you to use the actual spreadsheet in terms of the income statement, pull out the fixed cost from the calculation, and then there will be assumptions provided based on your sales. Okay, because not all units will be sold at the same price. So there are assumptions that you would have to make. Okay, what I was trying to do here, this is break-even point, looking at one particular product. Okay, so this is one unit. This is a selling price for a product, one product. Does that make sense?
Yes.
Okay, which is different to what you're doing on an income statement, because the income statement is looking at total sales, not individual sales for individual items. So maybe just a little disclaimer here. This is more management accounting. Okay, this would be detailed internal tracking for each product. Okay, so you could look at each product's, oh, I lost the, ooh. How do I go forward now? There we go. Okay. All right. For a product, for each product. Does that make sense?
Yes.
Okay. All right. Just be careful. This is for an individual basis product, and then look at the totals. But if it was a total, in other words, a income statement, then you would have to assume these amounts. Okay, you would have to assume a per unit cost. You'd have to assume a total variable, a total unit cost. With price per unit, you could then intuitively say total sales divided by all the units. Does that make sense? Irrespective of the unit, eh? So how many items did I sell? All of it. What was my total revenue? All of it, and then just divide it. Does that make sense?
Okay. Yes.
Okay, for the business. So the business might be selling like laptops, phones, tablets, and all of that. They could just say, well, how much total sales did I make? I don't know, maybe 100 million divided by how many laptops, tablets, cell phones, all of that did I sell? Maybe, I don't know, like 250,000, whatever the case might be, and then just get a general price per unit. Okay, or it'll have to be a lot more than that. Okay, these numbers are not realistic. Okay, make sense?
Yes.
Okay. Right, leverage, we saw that in the textbook now. Degree of operating leverage, DOL, this is revision from your previous module, and then financial leverage, DFL. All right, and then with the two, you can work out total leverage. Remember that?
Yes.
Okay, those workings, how comfortable are you with those workings?
I think I'm pretty comfortable. I guess I just need to revise them.
Yes, okay. Here's a good example of where you can do the total leverage, operating leverage, financial leverage. Okay, and then the total leverage. Right. In one of your slides, I actually tried to show this as well. I don't know if you saw that. Let's do this quickly. This is a nice question. I like this question because it has separate. Okay, I'm just going to use a separate sheet for this one. Okay, let's just give it a name. What page is this on? Page 40. Okay, on page 40, you've got all this data. Let me see if I can copy this directly. It will save a lot of time. Ooh, yes, kind of. All right, so it does work, but we just have to do it individually. Oh, Yeah, I can't select one column. Okay, we'll make this work. Okay. Yeah, the amounts, eh? Actually, I think I can do something here. Yes. Okay. I don't want spaces. Oh, spaces I do want, but now it's gonna put it like that with the rand figures. Okay, all right, let's fix this quickly. We need to remove all of the spaces, but that's gonna create a problem. All right, it's fine. Let's just do what we had there. Oops. Okay. All right, that does help a little bit. Or custom, can I custom? No, I can't. Okay, yeah, that kind of helps a little bit. Okay, but not a lot because of all the spaces. Okay, yeah, didn't really help much. Okay, I think let's just leave it and let's just put it in. Okay, so five years. Do they give you any of these like do they give you these like data things as a separate thing? Like do they give you an Excel spreadsheet with all these numbers? Because I remember when I studied, normally when they give you data, they give it to you in an Excel spreadsheet, so you don't have to do this. Do they do that or not?
No.
They don't, eh? Okay.
No.
Because, yeah, somebody would have had this written in Excel, so then they could have just shared that file with the students, and then students don't have to do what we're doing now to create this or to answer this. Okay, it does take a bit of time, but we're almost there. Last one. Okay, done. Finally, good. Okay, so we've got all of those columns. Okay, we've got all of those things. All right, so what are they asking us to do? Use regression analysis to estimate sales and cost of sales for 2021. Okay, that's a nice question. Why? Undo. Okay, there we go. Okay, so earlier we had it. Let's go back and just take what we wrote there. All right, so to work out the intercept, we are looking at sales and cost of sales in order to do the regression analysis. So to get the intercepts, we need the independent values. So let me ask you this, okay? What do you think is independent? What do you think is dependent in terms of cost of sales and sales?
The cost of sales
would be which one?
Independent.
Independent, correct. Okay, you decide in terms of manufacturing how much costs go into manufacturing a specific product which should ultimately, hopefully, have some sort of relationship with your sales, right? So Y would be dependent. So the sales would be dependent on the cost of sales. Highlight the 2, close brackets, enter, right? Intercept, okay, it's negatively correlated. Interesting. Okay, let's check the slope. Oh, intercept. Actually, that's the intercept, not negative correlation. Sorry, that's my mistake. Right, the slope is what we're looking at. That's what we need to see. Okay, this is Y dependent. So this set of data compared to that set of data. Okay, yeah, that's better. All right, so slope is positive. Okay, correlation coefficient. Okay, 0.9. So it is very highly correlated, positive correlation here. Okay, positive correlation because of this high value, 0.986. It's almost 1. So there's a very, very positive correlation here between cost of sales and sales. Okay, all right, we've done the first bit. Create a forecasted income statement for 2021 using estimates from A. Okay, interesting. All right, so 2021 is the next year. Do you agree?
Yes.
Okay, so they want us to forecast (2021). That's what they want us to do. And they want us to forecast 2021 based on the equation y equals a plus bx, which is your linear equation for regression. Okay, our A figure is that. So if we are predicting, okay, cost of sales, right, we're forecasting the income statement for 2021 using the estimates from A. Okay, so if we're looking at this, okay, all right, we're forecasting our sales, right, which is Y. Okay, we need X. Okay, X is the cost of sales for 2021. Do they give you any projection here for the costs? What do they say here? They must give you some sort of projection for the costs, because we can't just thumbsucker a figure. They don't mention anything there. What we could do is we could look at the current cost that you have here as a percentage or an average. Okay, so costs 2021 is predicted to be the average cost for the last 5 years. Okay, so I'm taking an average because I wasn't given anything in the question. Do you see why I'm using an average? Does that make sense?
Yes.
Okay, I'm using an average because I wasn't told how the costs are going to change from this year to next year. Okay, yes. I don't have an expectation. I wasn't told anything about the costs. Okay, so what I'm saying those were my costs for the last 5 years. So an average is quite a good estimate of what the cost could most likely be in 2021. Does that make sense?
Yes.
Okay, so I am projecting, okay, I'm estimating costs for that year based on the average of all of those years. With me with that?
Yes.
Okay, just as an estimate because you weren't given anything. Right, to calculate the sales, I do need to use this equation. All right, so my Y, my sales will equal this figure plus Okay, this figure multiplied by that figure. Put that in the brackets. Okay, and I would expect my sales for this period to be 7,400. Does it make sense?
Yes.
Okay. Calculate the degree of operating leverage for 2020 and a projected value from the projection in B. Okay, so you're looking for degree of operating leverage. All right, so you need that from your textbook. This is page 200 and something. DOL, we need that formula from finance again, eh?
Okay.
Let's go get that equation from the textbook. I'm going to use the one in the textbook because they'll be using it here. Okay, there we go. Summary of equations, page 215. Okay, they want us to use the DOL, right? Wasn't that what they asked you? DOL for 2020. Okay, so degree of operating leverage. The formula, degree of operating leverage, where's the equation? It's there. Degree of operating leverage.
Is it sales minus variable costs over earnings before interest and taxes?
No, it's that Q, change. It's change in EBIT divided by change in EBIT. Sales, sorry, yeah, sales. So I'm reading it wrong. All right, yeah. Okay, you've got it right, the right thing. Change in EBIT divided by change in sales. Okay, which is in brackets in the numerator, the quantity times price minus variable costs. Okay, close brackets divided by another bracket, quantity, brackets, P minus V, which is the same figure actually as the top, minus the FC. Okay, so it's basically the same numerator, the only thing with fixed cost at the bottom. Right, so if we had to do this calculation for 2020, so for this one, okay, what was our quantity? Do we have that quantity here? No, we don't. Okay, so we do need to use the change then. Okay, so we need to use the change. We need to use the change in EBIT and the change in sales. So I'm just going to put an extra column here. Okay, we need to look at the change. All right, so what was the change in EBIT from 2019 to 2020? So the change here, to work out a change, I don't think you can do this in Excel. Yeah, you can't. You'll have to use normal maths. Okay, this is what it was minus what it is now. Oh, what it is minus what it was. Sorry, other way around. What it is minus what it was divided by what it was. Okay, times 100. That'll give you a percentage. Okay, so there, it's a 16,66666% change in EBIT. Okay, what is my change in sales? Same thing, copy, paste. Okay, was it exactly the same? Wow. Is it the same? Yeah, D3, F3, yeah, wow, okay. So it's the same change, it both decreased. So if we're looking at DOL, the change in EBIT was negative 16.66666. The change in sales was negative 16.666. So the degree of operating leverage would be 1. Okay, equals, you would have this, change in EBIT divided by change in sales. Okay, degree of operating leverage would be 1 for this business. Right, then we need to project calculate DRL for 22 and projected value from projection B. So projection B, which was this. So we need another line here. Okay, so fixed costs, it's all 1,000, so this will stay 1,000 in 2021. Okay, interest will be 100. Okay, so the EBIT here, oh, we don't need the rest actually. All right, so we just need EBIT. What would EBIT be? Do these figures match? No, they don't. Okay, so you're gonna have to estimate that as well. You'll have to average it out. Average. Okay, and then we need to look at the change. Okay, so the change in EBIT here would be open brackets, this minus what it was, close brackets, divided by what it was, times 100. Okay, and then do the same thing for there. Paste the formula. Come on, there we go. Okay, all right, so that's a nice one. All right, so change in EBIT, so this would be DRL for 2021 would be the change in EBIT, which was 108.333 divided by 48. So this figure divided by that figure. So degree of operating leverage expected for 2021 is a bit more, 2.25%, based on what we expect. Okay. Is that all right?
Yes.
Okay. All right. The last section, we've actually looked at a lot. So I don't know how good or bad your time value of money is. So I want to ask you, do you have any problems with time value of money, just in terms of the theory? So when you read all of these key concepts, are any of them unfamiliar based on what
Not
you've covered
really,
in FIN
no.
2601 and 3701?
Yeah, I think I did quite a bit of time value of
Yes, yeah,
money.
you've done a lot actually when I look at your other modules. So the first one is just look at amortized loan. I'm going to show you how to do that. Okay. All right, an amortized loan is just a loan agreement, okay, where you have a particular bond that you're paying off. All right, future value, present value, and annuities. Let me show you this. All right, with time value of money, it's very simple. You can do all these workings. So let's just do one example. Okay, do you have your financial calculator close by?
I do.
Okay, can you quickly work this out on your financial calculator?
Okay.
What's the future value?
Is it compounded monthly, you say?
Yeah, so remember I-12, you need to divide by 12, so 10 divided by
Yes.
12. Which calculator do you use, the HP, the Sharp, or the Casio?
Sharp.
Okay, Think you got an answer for us?
Almost.
Almost, okay. Remember, don't forget to change your years to months, eh?
Yes.
Good.
Is it 6,098 Rand 40?
Like that?
Yes.
Okay, let's check. All right, so Excel, you've got a function or a formula that can work out time value of money. Okay, it's all easy to note. It's just FE. So if I want the FE, I type in FE. All right.
Okay.
Then I put in my rate. In Excel, you've got to show it like this. Must be a decimal. Right. So in my question, I've got 10%, so 0.10 divided by 12 because this is a monthly rate. Okay, the rate needs to take compounding into account. In other words, you're inserting your effective rate. Does it make sense?
Yes.
Okay,
Yes.
then comma, n is the number of periods. So in this case, 5 times 12, because I have 12 months. Okay,
Yes.
let's put that in a bracket just in case. Oops. Okay, and then next line item is the payment. There is no annuity here, so we would show a 0. Okay, then we have a present value of 10,000. The same thing applies on Excel. If you put in a negative, your answer will come out as positive. If you put in a positive, your answer will come out as negative. Does it make sense?
Yes.
Yes, it's normally cash flow. So we'll assume it's an outflow. I'm going to invest 10,000, so it'll be an outflow. Right. You can change the type. If you want it beginning of the period or end of the period, you can put a 1 or a 0 here. Right. They're just showing you the type. You don't need the type. Okay. It won't make a difference here. If I put 1 or 0, it'll still give me the same answer. Okay. That's just for annuities. Annuities due or annuities, ordinary annuities or annuities due. Okay. Let's check the answer. Ooh, it's different. Something went
I put
wrong.
1,000 Rand instead of 10,000.
Oh, did you put 1,000? Okay, let's
Yes.
change it. So I'm going to quickly delete a 0.
Sorry, it's just so small that I
Okay, no, it's
didn't
still
see
wrong.
it.
If you put 1,000, it's still wrong.
Okay.
Okay. All right, on your calculator, financial calculator, let's practice this quickly.
Okay.
Okay, you need to put in N as 60. Okay, your PV will be minus 10,000. Your I must be 10 divided by 12, which is what? Let's work that out.
0.83.
Yes, okay. So you put 0.83333333, all right, and then you solve for future value. Try that.
Yeah, got it. It's
This one, eh? Same figure, right?
yes, yes,
Okay, yeah, it must be the 16,000.
yes.
Okay, so yeah, you should get the same answer whether you're using the calculator or whether you're using Excel. Okay, all right, and you can work out the PV as well. Same formula, all right? If you had to work out the present value, okay, you would also just follow equals PV, open brackets, and then you would insert rate, number of periods, if there's a payment, so an annuity, and then the future value is what you insert. Right, you can also identify whether this is at the beginning or end. It won't make a difference though for the PV. Okay,
Okay.
all right, happy with this?
Yes.
Okay, I think they might even have mentioned that, yeah, see, second level of finance, you should be aware of these concepts, so a little bit of revision. All right, so please have a look at that. If you have any questions, you can ask me next time if you struggle with any of these. Annuities are nice because this is for a bond. All right, an actual bond calculation. So I want to make this real as possible. Okay, all right, so you might have a bond, okay, on a property. So give me a price. How much, if you could buy a property, okay, whatever property, doesn't matter, how much would it cost?
You mean my bond payments?
No, I want to know the price of the
actual
house that you
cost.
want to buy. The house that
Let's
you want to buy.
say
You can make this even like a dream or a goal, like your dream house. How much would it cost?
maybe about 8 million.
Hey, let's do the workings on 8 million. Okay, all right. So if the house price is 8 million, let's assume the bank wants a 10% deposit. Okay, so you're going to finance your home loan principal amount. Yeah, I'm not going to take cost into consideration, right? No fees, no monthly fee, whatever. I'm purely looking at the outstanding liability, right? So if you had to pay a 10% deposit, right, and I'm looking at 8 million, okay, times 90%, right? I'm going to finance 7.2 million with the bank. Okay, let's just make this let's change the format. That wasn't right. Let's make it there. Okay, ooh, rand figures. It doesn't matter, it's fine. Or let's change it. Okay. Oh, South African rand. Is it there? It should be. Yeah, there we go. Okay. All right. So if you're financing 7.2 million, okay, how long do you want to finance for? What's the term?
20 years.
20 years. Okay. All right. So just as a tip, okay, normally when you're financing a home loan, for every million, right, it's basically 10,000. So you're probably going to pay around 70,000 or 72,000 rand a month to finance this property through the bank if you had to take out finance for it. All right. The prime lending rates didn't change last week or the week before when they had the MPC meeting, 11.25%. Okay, also assuming maybe you're better, your credit profile is better, you might get prime minus. If your profile is worse, you'll get prime plus. Right, we're just going to assume prime is what you're going to be getting from the bank, all right, and that's the rate. Okay, so what do we need to do? We need to draw up an amortization table. All right, I'm taking two things in one year. The annuity is the monthly recurring payment. Okay, later on, I think I saw there was a note here about an annuity, not an annuity, an amortization. Where is it? Okay, yeah, cash flows. Here's the compounding. Oh, it was earlier actually, not there. All right, so here they were just talking about compounding and cash flows if it's uneven. This you can actually draw up in Excel, but you'll use different cells. Okay, you'll use different cells representing cash flow. Very similar to net present value, hey? That we'll look at next week actually. And you'll see different types of examples. I'll show you how to do NPV and IRR on Excel. Okay, where was I here? No, the annuities there. Okay. All right, so when I'm looking at an amortization table, the first thing that I need to do, obviously there's going to be a principal amount, okay? What is the principal amount representing? Well, the actual loan amount. Okay, there's going to be interest that's going to be, inverted commas, added, okay, to the loan every month. And then obviously you're going to be making your payment or your installments, your debit order. Okay, and then after you've made your payment or your installment, you're then going to have the balance that's outstanding. Does that make sense?
Yes.
Okay, so that's basically how the table works. Very basic calculation. All right, obviously if I start with a particular amount, okay, that amount is going to attract interest, okay, and then there's going to be an installment that's going to be part of it as well. All right, so first step when you're doing any calculation looking at loan amortization or liabilities, you need to first calculate the monthly installment amount. Okay, the monthly installment amount is calculated using the assumed variables that we just discussed. Okay, just remember, in reality, the rates can change. Okay, if the rates change, then you would have to update the table, and you'll have to update the table for the change in rates, and then your installment will change. So if the rate changes, the bank will update your monthly amount. I'm sure you might have seen this. If you do have a home loan or any form of financing, when the rates were going up a few years ago, okay, the rates have stayed flat for the time being. But when the rates went up, then those installments were changed. It also went up. It went up by maybe 100, 200, 300 Rand, depending on the size of your mortgage. Does it make sense?
Yes.
Okay, so this calculation is always what we need to do first before we draw up the table. Right, so this calculation is done, and there's a lot of great tools out there. You can actually do these calculations on a what do they call those things? There's like, it's like a calculator, but it's a website that has like these even banks have it. Banks will give you a installment calculator or a credit agreement calculator. There's always these tools that you can use to help you. Okay, if we're doing it using our time value of money, using the math that we know, using the formulas we know, using the PV, the FV, all of these formulas. Okay, there's those. See the formats from Excel. Okay, first thing we need to do is to work out. So let's do the N. How much N do we have?
So it's 20 years times 12. Yeah.
Correct. 240 months. All right, your interest rate, we're assuming, is going to be flat, okay, for the total duration of the loan. Right, obviously, if it changes, we would have to change it, right? So we said 11.25% divided by 12 is 0.93% per month, okay? We set the principal, so the loan amount was the 7.2 million. Okay. What else do we need? That's it. Solve for the payments. Okay, grab a calculator quick. Do the working, and then we'll use Excel. What's the monthly payment? Should be around plus minus 70,000, 72,000, somewhere there. It's normally around 10%, not 10%. It's normally every million, it's normally 10,000. Yeah, so on a million Rand property, you're probably going to pay around 10,000 Rand a month. 2 million, 20,000, 3 million, 30,000. This is 7 million, so plus minus.
It's 75,500.
Okay, let's check if you're right. Okay, so remember we're using Excel. To calculate the payment, I put PMT into the formula. Payments. I need the rate. The rate here was 0.1125 divided by 12, close brackets. Okay, the number of periods was 20 times 12. Okay, the present value was the outstanding loan amount. Okay, because I'm amortizing the loan, I'm getting money initially, so I'm going to put this as a positive. Okay, 7.2 million. All right, we're going to assume this is a normal, okay, annuity, so we pay the installments at the end of the month, not at the beginning of the month. Does that make sense?
Yes.
Okay, so we're not going to change the setting. Right, perfect. Well done. You got the correct answer. It is. The rands aren't there again. Okay. Okay, it is 75,000 a month. Okay, to finance this property over a period of time. All right. Are you all comfortable with the work you did so far?
Yes.
Okay. This payment amount is the amount that we just calculated. All right. So we need to show that figure in there, except I want to make it a number. Okay. And I want to show you how this works. All right. So I want to make it a positive as well. So I'm just going to make it a negative. All right. So that's your installment. Do you agree your installment is going to decrease the value of your loan, right?
Yes.
Okay. You started with 7.2 million, right? Okay.
Yes.
Remember, interest is going to be charged monthly. The bank is going to charge you interest. So they're going to take this amount and they're going to multiply it by the 0.1125, okay, per month divided by 12. That's the amount of interest in the first month. Okay, that interest is going to be added to the principal. Do you agree?
Yes.
Okay, the balance outstanding is going to be this principal amount, okay, plus the interest minus the installment gives you the new balance. Are you with me?
Yes. Yes.
Okay, that balance is now going to carry forward, okay? You are then going to have the same working. This times 0.1125 divided by 12, right? There's the interest. The payment will stay the same, okay? And then you'll have a new balance, which is the principal plus the interest minus the installment. Right. Notice the balance is slowly decreasing. Do you agree?
Yes.
Okay, I forgot to add a column here, the month. All right, month number 1, month number 2. Okay, how many months did we say we're going to have this loan for?
240.
Yes. Long time to pay off a loan, eh?
Yes.
Okay. All right, but hopefully you're intelligent and you manage your finances carefully and you pay off the loan earlier so then you don't have to pay all the interest.
Yes.
Okay, so look at this. All right, we've done all the workings. We can just take this. Let's just make the formatting a bit nicer. Let's use currency. Let's use accounting. Okay, but without the rands. Well, we can put the rands actually. Why not? All right. Okay, have a look. Copy, paste. Loans getting smaller and smaller and smaller and smaller. If you do this for all of the months,
Wow.
that's why Excel is so powerful. You will see you get to 0.
Yes.
Okay, because you have to pay off your loan at that period of time. Notice as you get closer to the end of the loan, you pay off more of the principal, you pay off less interest because the loan doesn't get as much interest. Do you see that?
Yes.
Okay, and remember, if we have to sum up this column, okay, this is how much interest you're going to pay over the life of the loan.
Wow.
Right, and that's why when you sign your bond agreement, when you go to the attorneys and you sign all those documents with the attorneys, they have to disclose this. The bank tells you in your legal document, they say over the life of your loan, remember with fees included, then they show you how much they're charging you, and they have to disclose the interest as well. All right.
Yes.
Okay, so you're not only paying for the principal. Remember the principal, okay? The total principal was it was a 7.2 million rand loan. Remember that?
Yes.
Okay, but look at how much you actually pay. If I sum up all of these amounts, okay, all right, I actually end up paying 18 million for a 7.2 million rand home. All right, that's why banks are never ever going to close, because banks make a lot of money from their clients because of the time value of money. Right, remember, every month for the next 24 months, you're going to be paying 75,000 in total payments or repayments. Okay, over the 24 months, over the 240 months, over the 20 years, you would have paid 18 million. Okay.
It's more than double.
It is, and that's why when they disclose this to you as a client, they show you the interest and they tell you, then they even show that you're right, it is about double, hey? So this divided by 7.2 million, all right, it's about 2.52 times. You see that?
Yes.
All right, and that's normally what they would disclose to you as the client, all right? They'll say, in actual fact, you're paying almost 2.25 times this thing. All right, but notice, okay, let me show you something useful here. I'll send you all this so you have it. Okay.
Yes.
Let's assume, do you agree? Okay, so if you have to pay off your loan earlier, let's assume you've got an extra 10,000 lying around, okay? And you want to pay off an extra 10,000 Rand in month number, let's say 12. Okay, at the end of December, you get a bonus, okay? You've got an extra sum of money. You want to pay some of it off, okay? Have a look at this. If I take this amount and I just subtract 10,000 Rand from it, okay, that's going to update everything. And if you go down to the bottom of the spreadsheet, okay, you will see you start paying, okay, you pay off the loan a little bit sooner. All right, so you will actually pay off the loan here. Do you see that?
Yes.
Because you've paid off earlier, you're going to save yourself. This amount here is the savings that you have over time. Remember the power of compound interest?
Yes.
Right, so if you can pay off your home loan sooner, let's assume you can put in even more money. Let's assume your bonus is even bigger, okay? Let's assume at the end of the month in December, you get a nice big bonus, let's just say 100,000, and you put all of that into your home loan. Okay, if you put 100K into your home loan, look at the balance being updated. Okay, you're still going to pay the same installment. We're going to assume the installment stays the same, but notice how much interest you save. Let's go down to the bottom. Okay, look at that. Look how much interest you're saving, and your last installment would have ended around there.
Yes.
Okay, so this is just basic like financial management, personal finance, right? That's why if you do manage your debt carefully, and you could even do this with a car, you could use a car finance arrangement, whatever the case is. But the point I'm trying to make here is this is a loan amortization table where you've got separate line items. Okay, this installment can change depending on the interest rates. Okay. Is that all right?
Yes.
Okay, so this is just a good example just to explain this concept of a loan amortization, highlighting three things. Annuity, so an annuity is a recurring payment, okay? And then obviously present value, future value. Future value in this case will always be zero. You don't have to show that. Okay, we don't write FV equals 0. You could put in FV equals 0 here, and then do the working. It won't change the answer in any way.
Okay.
All right. Okay, I'm almost done. I think we've covered everything there. Okay, these are very specific types of annuities. Deferred means you leave it, okay, till later. Right, if you don't pay, so for example, let's assume you get retrenched and now you can't pay the installments. All right, and then the balance is going to go on and on and on. That's either going to lengthen the time or it's going to increase the installment. Does that make sense?
Yes.
All right, so a deferred annuity means when you start paying something or when you start receiving something at a later point in time, not immediately. Okay, so that could be like saving up for retirement. That's the example they've given you here. Right, I'm going to save up to retirement. I'm going to save towards retirement, but then I'm not going to retire immediately. I'm going to put the money away for some time, and then only after maybe 5 years will I start drawing down on that investment.
Okay.
Make sense?
Yes.
Okay. All right. I think I've covered everything. Maybe please just for the sake of time, can you maybe look at these examples? If you do struggle with the workings on Excel, let me know. I can quickly show that to you next time. But go through it on your own and see if you can do these calculations. I don't think time value of money is going to be too much of an issue. Remember, it's all basic formulas, right? Remember, equals PV, right, for present value, equals FV for future value, okay, equals PMT for an annuity, a payment.
Yes, okay.
You do have other functions. You can work out cumulative interest and all of that. That's just additional Excel. For example, here, we had this loan amortization. We could have actually used Excel to calculate the cumulative interest. All right, we can use one of the functions. It's very powerful. Okay, now let's just see if we've covered everything. Just going to quickly scroll through the last few notes. Yeah, they're just giving you some examples here. As I said, please look at these examples. If you have problems, let me know.
Okay.
We can discuss it next week. And then, okay, cash flows, we'll do a lot of that next week because of, what is it called? Capital budgeting. Okay, we have cash flows. Net present value, IRR, we'll do those workings. All right, so I'll show that to you. So cash flows can also apply here with those annuities. Graduated, I think with this, they're looking at an increase, growth rates. Right, so you can increase certain cash flows. You can increase the amount that you're contributing. So this would be, I see they call it a graduated annuity. It's also called a growing annuity, right? Growing because there's a growth rate. So this could be something like, for example, let's assume you're saving for retirement. And every year you're going to increase your contribution by 5% to make up for inflation. Does that make sense?
Yes.
Okay, so when you're looking at a future value, you can put in a growth rate to increase the amount that you're contributing. Maybe let me just show you the the formula. Future value with the growth rates. Did it come up? Oh, no. Okay, we need to go into the actual formula. Future value. Forecast? No. Okay. All right. I think if we use this, I see they don't give you the one with the growing annuity. This also might be a slightly outdated variation of the textbook. It might be a different formula now on Excel. Let's just quickly Google this and check. What is the growing annuity in the new Excel, the latest version of it? Let's just Google quickly here separately. Excel growing annuity formula. Let's see what comes up. Okay, I see here, they've given you a note. Okay, I'm just reading what I'm Googling on Excel. Growing annuity, they've used a table. There's not a specific function. Okay, that's NPV that we'll look at next time. Yeah, Microsoft. All right, looks like it might have changed. I'm not sure if they've removed it perhaps, but it's not coming up when I'm searching for the function. And I see here you're using this notation. So let's type it as is, FAM. Does it come up? No. Okay. I don't see it on Excel. To calculate the future value of a graduated annuity in Excel, we use the FAM underscore. It's not coming up. FAM underscore FVGA. Okay, let's put in a rate. Let's put in 0. Let's say 10%. Let's see what we get. Let's put a growth rate of 5%. Okay, let's put number of months. Let's just say 12 months or a year. The payment we're going to be putting in, let's just say 1,000 Rand. Okay, comma, the present value. Are we going to put a present value here? So we're going to start with an amount. I'm going to say 0. We're going to start with nothing. Okay, let's enter. Yeah, I don't know why, but it looks like the function has been removed from this version of Excel. These formulas don't actually exist now based on what we've tried to insert here, which is strange. Did they give you any annexure for this study guide?
No.
Okay, because this might be a slightly outdated version of it. I do have an older version of Excel. I'll try it and see, but I don't know if it'll work. Let's see. Okay, because normally if it's a growing annuity, you would draw up a spreadsheet for it, and then you would see if it works. Okay, so this is a older version of Excel. So let's see if it comes up. Let's copy what we had earlier. Let's see if it works. Nope, also doesn't work. All right, I don't know what they mean by this thing. This is a little bit strange. Can you check with them? Maybe just ask a question, because when I Google this on Google, Microsoft Excel, and I typed in annuity. This is basically what I typed in a search box. Microsoft Excel growing annuity formula. I don't see one for it. The only option I see here is for the present value. With a growing annuity, you do treat it a bit differently. There is a way to create it, but I don't know if there's an inbuilt function that provides for the growing annuity. I don't see it here. Formula for, yeah, I don't see it here. I don't know if it's an inbuilt function, because I know in financial mathematics, they give you a formula for it, but it's an actual formula for it. It's not a function. Let me show you what I mean. I'll quickly open up. Okay, so in DSC 1630, that's the financial maths module. Okay, let me just open up. Do I have a study guide? Is this the study guide? No, this is the assignments. Let me show you the formula, or let me open up a past paper. That's even better. Okay, in the past paper, they show you the equation for a growing annuity. Let me open up an old exam here. Just find anyone, doesn't matter. Okay, so let me just bring this across so you can see it. Okay, so this is the DSC module, looking at financial maths. Have you done this module, the DSC one?
No, I have not.
Okay, yeah. This is very, very, very much financial mathematics. At the end of it, they give you a formula sheet. Let's find it. Yeah, here's the tables. There's the formula sheet. Okay, and for a growing annuity, where's the one for the growing annuity? I'll find it now. Where is it? It's this one. Okay, there's the equation for a growing annuity, right, where you have an amount that's being added or increased, okay, where the actual amount increases by a specific value. So if it's 10%, you'll increase it by 10%. So 10% of the amount, you need to add it to that amount. Okay, so it's a formula. It's a very, very specific formula that speaks to time value of money. I don't know if you can do it using an inbuilt equation. That was new. I haven't actually seen that before. So yeah, this This I'm a little bit suspicious of. I'm not too sure how they're doing this using Excel because we can see that doesn't actually exist.
Okay.
Okay, so maybe ask that
Maybe I
question.
can just send them an email, like to one of the lecturers.
Yeah, please do. Just ask them about this section here because in Excel, like if you literally if you type in what they've given you here and you put that in Excel, Excel doesn't recognize the formula, which is a problem. Maybe this is a bit of an outdated text that they need to remove, perhaps, right? Or there might be other functions that there could be in a paid version of it. I don't know. I'll try it work when I have my normal 360 and I'll just type this in and see if I get more options. But having Googled it, I don't see it coming up, which is unusual because you can work out an annuity, but we know that and we have that. So it's just a growing annuity. Or let's type the word graduated. Let's see if graduated annuity comes out. See, also nothing. All right. Yeah, so I'm a little bit confused when it comes to this section here in the study guide from UNISA. You're going to have to just check with them to see what are they referring to there. Right, NPV and IRR we'll cover next week, so don't worry about that. Continuous compounding uses E. Okay, you can also insert that into your calculator. That's not a problem. Continuous compounding is fine. All right, that's just looking at with that little E. Do you know the maths? You know that maths symbol E, like log base E, the E.
Yes, yes.
Okay, that's fine. All right. When you have continuous compounding, then you do use that E function. Okay. All right, Prosha, I'm going to wrap up there. Sorry for going a bit over, but at least we covered
No
everything.
problem.
All right. Any questions? Are we all right for this week?
Yeah, I think we're good.
Awesome. Right, then I will see you next week again. We have the last two. I don't think the next one will take that long because we've covered the bulk of it now. You'll see they talk about financial assets, which is basically time value of money, but applied to bonds, okay, or shares, depending on what you're valuing, right? And you've done your financial management modules. So we actually did do bond pricing and share pricing as well. So a little bit of revision, dividend discount model you're familiar with. This is the only thing that I think I might need to explain, duration and convexity, because that's from investment management, actually. I don't know if you've done the INV modules, the 3701, 3702.
Yes, I did.
Oh, you did? Then you're fine with that, actually. Okay, that's good. Well done. Okay. All right. See you next week then. Enjoy the rest of your weekend.
Okay. Thank you very much, Anthony.
You're welcome. Well. Thanks.
I'll see you next week.
Yes, Prosha. Okay, take care. Until then.
You too.
Okay, bye.
Bye.